Well, let's take a look at number 18. Identify the graph of the inequality. Basically, graph the inequality. So we got y is less than or equal to x squared plus 3x. And actually, I don't know why I was drawing the box first, but okay. If you have a less than or a less than or equal to, then that means you're going to have a lower left-hand triangle. If you have a greater than or equal to, that means you're going to have an upper right-hand triangle. Now, if you have a less than or greater than, you're going to use a dotted line. If you have a less than or equal to or greater than or equal to, you'll have a solid line. Now, the ones that are perfect for a calculator for these, where you're graphing, where you have two variables, x's and y's, is where you can get to y by itself easily. Sometimes if you have y squared here, you get it by itself, but it wouldn't be very easy. So this is already by itself, so it works out perfect. So let's graph this. Come over here, press y equals, press clear. I'm going to put in x squared. So I'm going to do my x key, x squared plus 3x. Now look where our cursor currently is. I'm going to press my left arrow key and keep pressing it until my flashing cursor is on this first slash. You can't do it too many times. Now this problem is a less than or equal to, and we said less than or equal to is going to be the lower left-hand triangle. So let's see what that means. I press enter one time, becomes a thick slash. I press it one more time, becomes an upper right-hand triangle. I press it one more time, becomes a lower left-hand triangle. And then we push the graph. Now the only thing that this doesn't give you is it doesn't give you the whether it's a dot or a solid line. So if I come over here, since it's a less than or equal to, that tells us it's going to be a solid line. And when I say solid line or dotted line, I'm talking about what separates the shaded region from the non-shaded region. So they're telling us that that's going to be a solid. And then we got this shaded right here. And that'd be our answer. So let's see which one it matches. See, A would be close, except for that's a dotted line, dashed line. So it'd be C. So our answer would be 18C. Which matches. Now if I was doing this by hand, what we would do is, let me show it. We got y is less than or equal to x squared plus 3x. First thing we do is we pretend we're graphing y is equal to x squared plus 3x. With the stipulation of the dotted or solid line. This is a less than or equal to, so it's going to be a solid line. Now this is a quadratic, and different ways you can graph it. You could find a vertex for one way. Our vertex, we plug in the a and b into this formula, so it would have negative 3 over 2 times 1, which would give us negative 3 halves. And then you take that negative 3 halves and you plug it into your original function, and we'd have negative 3 halves squared plus 3 times negative 3 halves. Well, that gives us 9 fourths minus 9 halves, which would give us 9 fourths minus, now multiply the top and bottom by 2, so 18 fourths, which gives us negative 9 fourths. So I did my math right. So our vertex is negative 3 halves and negative 9 fourths, which is negative 1.5 and negative 1 3/4, negative 1.75. So there's negative 1.5 there, negative 1. So it'll be about right there. If I plugged in 0 for the x, I'd have 0 squared plus 3 times 0. That'd give us y is equal to 0. So I know it passes through here. So you have that. And this, by symmetry, this side will look pretty much the same like that. Then what you do is you pick a test case. It doesn't matter what. Origin wouldn't be good because it passes through the origin. Maybe 0, 3. 0, 3 would be right up here. You plug that into your original inequality and see if it's true. So our inequality up here. So we got y is less than or equal to x squared plus 3x. And this is our x and this is our y. So put 3 in for that. This is more of a question mark at this point. 0 squared plus 3 times 0. Zeros are always good to choose. And 0 squared is 0 plus 3 times 0 is 0, so all that's 0, and that's false. Now since that's false, if it was true, we would shade the side where that point falls. But since it's false, that means we'll shade the other side, which the other side is this over here, which would give us the same graph.